Hey, Math 10C, we're going to go through lesson 2.5 using the sine and cosine ratios to calculate lengths. So just a review of last week, sine theta, sine of my angle is equal to my opposite side, divide by my hypotenuse. And cos theta is equal to my adjacent side, divide by my hypotenuse. Okay, so using the sine or cosine ratio to determine the length of a leg. Determine the length of BC to the nearest tenth of a centimeter. So side BC is this side here. We're given this angle. Across from the right angle is what we call the hypotenuse. And we're looking for side BC, which is right beside angle 50, so that's the adjacent side. Okay, so when I go back to my ratios, I'm going to use cos because cos uses adjacent and hypotenuse. So I say cos of my angle 50 is equal to side BC, which is my adjacent side, divided by my hypotenuse, which is 5.2. Now I'm going to make ratio equal to a ratio, and I'm going to cross multiply, divide by what's left over. So in your calculator, it should look exactly like this. 5.2 times cos 50 divide by 1 is equal to BC. Now we don't really need to write divide by 1 because we know anything divided by 1 is just itself. So that's 5.2 times cos 50. We should get 3.3. They want it to the nearest tenth, and that is equal to side BC. Determine the length, B says determine the length of side PQ to the nearest tenth of a centimeter. So here's my angle. Across from that angle is my opposite side. Across from the right angle is my hypotenuse. So I go back up to my trigonomic ratios and I check to see if it's either sine or cosine. Sine uses my opposite side and my hypotenuse. So I'm going to use sine. So I say sine of my angle, which is 67, is equal to my opposite side, which I don't know, it's PQ, divided by my hypotenuse, which is 10.4. Now I have a ratio set up to a ratio. I'm going to put sine 67 over 1. And the reason why I do that is so that it makes it easier for me to solve for that unknown value, PQ. So in my calculator, 10.4 times sine 67. Now I'm not going to put divide by 1 because I know anything divided by 1 is just itself. So 10.4 times sine 67. That gives me now it says to the nearest tenth, so 9.6 centimeters. And you know what, I'm just going to set this up a little bit differently here. I'm going to set this equal to PQ, and then we're going to do 9.6 centimeters is equal to side PQ. There we go. Okay, let's keep going to here. Example 2, using sine or cosine to determine the length of the hypotenuse. Okay, so I'm going to do the exact same thing. I'm going to label my sides and see which trigonomic ratio. So again, to review, sine of theta is equal to opposite over hypotenuse. And cos theta is equal to adjacent over hypotenuse. So I go to my triangle, here is my angle, across from that angle is my opposite side. And I'm looking for side DE, so this is the hypotenuse, let's call it DE. So opposite and hypotenuse is sine, so I do sine of my angle 55 is equal to my opposite side 6.8, divide by my hypotenuse, which is DE, put it over 1, now I have cross multiply, divide by what's left over. So again, I'm doing a ratio equal to a ratio. It's just going to look a little bit different in my calculator. So 6.8 divide by, 1 times 6.8 divide by sine 55 is equal to side DE. Now I know 1 times anything is just itself, so you can do that if you want, but you don't need to. So 1 times 6.8 divide by sine 55. That is going to give me 8.3 centimeters is equal to side DE. So we are doing the exact same thing every time. It doesn't matter where our unknown value is. I'm just going to set it equal to a ratio, and then cross multiply and divide. So B is the same. So I'm going to let you do B on your own, and we're going to keep going to example 3. So example 3, a surveyor made the measurement shown in the diagram. How could the surveyor determine the distance from the transit to the survey pole to the nearest hundredth of a meter? So here's the transit, here's the survey pole. I'm given this angle. This side here is the adjacent side. Across from there, the side I'm looking for is my hypotenuse. So remember, cos is equal to adjacent over hypotenuse. So I'm going to do cos of my angle, which is 67.3, is equal to my adjacent side, 20.86, divided by my hypotenuse, which I don't know, so I'm just going to label it as hypotenuse. Now I'm going to set it equal to a ratio, so cos 67.3 over 1. Now I can do that. It doesn't change the outcome of the answer at all. It just makes it easier for me to solve. So 20.86 times 1, divide by 67.3. So 1 times 20.86, divide by cos 67.3 will give me the length that I need, the hypotenuse. So that's 20.86 divided by cos 67.3, 54 point, it says to the nearest hundredth, so 54.05 meters is the length that I'm looking for. Okay, let's do one more. From the radar station, the angle of elevation of an approaching airplane is 32.5 degrees. So remember, angle of elevation is always from the horizontal looking up. So they give us this angle of elevation. The horizontal distance between the plane and the radar station is 35.6, so they give us that. How far is the plane from the radar station to the nearest tenth of a kilometer? Now again, they give us this required distance. That's what we're looking for. So we have the adjacent side, we have the hypotenuse, and that uses cos again. So cos of my adjacent side, 37.5, cos of my angle is equal to my adjacent side, which is 35.6, divided by my hypotenuse, which I don't know. Now I'm going to set this over 1. Now I cross multiply, divide by what's left over. So in my calculator, 1 times 35.6, divide by cos of 37.5 is equal to my hypotenuse. So 1 times 35.6, divide by cos 37.5. Remember, 1 times anything is just itself. So I get 44.9 kilometers is equal to my unknown length, my hypotenuse. So that's the length that I want. Okay, that's it.